Welcome, my dear learners. Today we are looking at radical equation. Radical equation, an equation in which the variable appears in the radicand is called a radical equation. The examples of radical equations are these are a few examples of radical equation. Now let's look at the steps involved in solving radical equation. Isolate the radical equation. Then use the principle of squaring. You solve the new equation, and lastly you check all the possible solutions to see which of them satisfy the equation. Now that we know the steps, let's try examples. So we have example 1. So using the principle of squaring, we are going to apply that. So we have So using the principle of squaring, we square both sides of the equation to do away with the radical symbol. So when you expand this, you are getting x squared minus 10x plus 25 is equal to x plus 7. You group like terms, okay? So we are getting x squared minus 11x plus 18 is equal to 0. Now when you solve for this is a quadratic equation, so when you solve it, the value of x is either going to be x is equal to 2 or x is equal to 9. Now after getting 6, the last step says check all the possible solutions to see which of them satisfy the equation. So you check. So at x is equal to 2, we are getting x minus 5 is equal to root of. So you can see that at x is equal to 2 doesn't satisfy the equation. So you check the other possible solution. So at x is equal to 9, So it means that the solution for this equation is x is equal to 9, and that is the answer. Let's take an example 2. We have to find x. So we are still using the principle of squaring, but this one we are not squaring, we are going to cube it because we have cube roots. Okay, so we multiply both sides of the equation by power of 3 to do away with the cube roots. So you group like terms from here, this will come here, and then this will go here. So you have 3x minus x is equal to minus 1 minus 5. We have 2x is equal to minus 6. Therefore, x is equal to what? Minus 3. Since this one we are having only one solution, we can check it to verify if it satisfies the equation, and it will surely satisfy the equation. So let's try the last example, and then we are good to go. Example 3, that's the last example. You have to find x. So we can still continue by applying our principle of squaring. So we are going to get so squaring both sides, we are getting 4x squared plus x minus 3 is equal to 4x squared. Now you can group like terms. Okay, so we have 4x squared minus 4x squared plus x minus 3 is equal to 0. This and that will go. We are left with x minus 3 is equal to 0. Therefore, our x is equal to what? 3. And this is the answer. You can check to see if it really satisfies the equation, and it will surely satisfy. Thanks for watching. Make sure you subscribe to my new channel. Let's look at the last example, and then we run out of here. We have to solve root of x plus 2 plus root of x minus 1 is equal to 3. We have to solve this. So what we are going to do is we first have to transpose one of the radical sign to the other side of the equation. So we are going to get root of x plus 2, which is equal to 3. We are going to bring this very radical equation to this side. So we are getting 3 minus root of x minus 1. So after doing this, then we square both sides to remove one of the radical sign. So let's square both sides. So after squaring both sides, we are having x plus 2. This one will give us 9 minus 6 root of x minus 1 plus x minus 1. So from here we can group like terms. So we are getting x, which is here, minus this x plus 2 minus 9 plus 1 is equal to minus 6 root of x minus 1. I hope you can see that. So you can see that this and that will go. Here we are left with what? 2 plus 1 is 3. 3 minus 9 minus 6 is equal to minus 6 root of x minus 1. So from here we can divide through by what? Negative 6. So at the end we are having 1 is equal to root of x minus 1. And then we square again to cancel or to do away with the radical sign. So squaring both sides again. You can see that the square and then the radical sign will go. We are left with 1 is equal to x minus 1. Grouping like terms, we have x is equal to what? 2. Now we can check to see if this solution satisfies the equation. So let's check. So at x is equal to 2, we are going to get root of 2 plus 2 plus root of 2 minus 1, which is equal to 3. 2 plus 2 is what? 4. Root of 4 is what? 2. 2 minus 1 is 1. Root of 1 is 1. And you can see that 3 is equal to 3. So this satisfies the equation, and therefore it is true. Thanks for watching.